Okay, I'm going to give you a quick overview of factoring polynomials, factoring trinomials specifically. So the key, this first one, lead coefficient's 1, so we don't have to worry about that. So how do we find what's going on here? So remember, we're going to break this up into two pieces that look like this, so that if we multiplied them out, we would get this. Well, how would we get x squared? Well, x times x, so no problem there. Well, how would we get 20? So what numbers could we multiply to get 20, but they also have to add to make 9. So that's the key. So factors of 20, add to make 9. Well, 4 and 5 are going to work. So x plus 4, x plus 5. And I know they're plus because they multiply to make positive 20, and they add to make positive 9. So again, think if I multiply this out, x times x, x squared, 4x plus 5x, there's my 9x, 4 times 5, hey, that's 20. Not too bad. How about this one? So again, think we're going to break it up into two pieces. Lead coefficient's 1, so in this case it's just n times n. Now, we want two numbers that multiply to make negative 50 and add to make negative 5. So you could start listing factors out if that helps. Negative 50, well, we could multiply 10 times 5 to get 50. They need to add to make negative 5 though. So it's going to be minus 10 and plus 5. Now I'm doing that pretty quick because I've done a lot of factoring. But if it helps, list the factors out, think about it. You may not get it on the first try. That's okay. So negative 10 times 5 would make negative 50. Negative 10n plus 5n, hey, there's our negative 5n. So lead coefficient 1, not too bad, okay? So let's look at the next couple. Notice they have lead coefficients. So this one's got a 4 out front, this one's got a 6. So what could we do in this case? Well, the first thing to look for when you've got something like that, and you did this the previous lesson, is there something in common we could factor out? Well, 4 is going to go into each of these terms. So let's multiply, or rather divide, factor that 4 out. So if we do that, we're going to get 4 times, well, what would be left? R squared minus 2r. How many times 4 going to 192? Let me tell you. 192 divided by 4, 48. So minus 48. Now I've got a trinomial just like these previous two examples, so we can factor it the same way. So 4, let's assume these are going to factor here. So all right, so now let's think what we just did up here. Now our lead coefficient's like it's a 1, so we want two numbers multiplied to make negative 48, add to make negative 2. Well, 8 and 6 comes to mind. So r minus 8, r plus 6, so we got negative 8 times 6, that makes negative 48, negative 8 plus 6, hey, there's our negative 2. Not too bad. Will a similar thing work for this one? Okay, let's try it. Can I pull a 6 out? So 6 times n squared plus, let's see, 96 divided by 6, 16, plus, what are we doing? 360 divided by 6, and we get 60. Okay, now we've got another trinomial, very similar to what we just did. So 6 times, now not every trinomial is going to factor, by the way, but these ones are, okay, because we're practicing factoring. That's why I'm automatically assuming these are going to work, and they are. So factors of 60, two numbers multiply to make 60, they will add to make 16. Hey, 10 times 6 sounds good. So n plus 10, n plus 6, again, 10 times 6 is 60, 10 plus 6 gives me 16. Kind of making sense, hopefully? Okay, let's mix it up a little now. Couple more examples. notice we do have, in fact, let me just fold this here so it's a little easier to see, sorry. So we've got now lead coefficients, but notice 7, I can't divide that 7 out. So there's a lot of different methods, there's a lot of different strategies to do this. Here's the key. This times this has to add up. We get a couple factors from that, and it adds to make that. So there's different ways to help you set that up. I'm going to show you one of my favorite ways that I found the last couple years from somebody else. I didn't make it up, okay? There's guess and check. You can honestly just try. There's not many factors of 7, so you could just draw your parentheses and start guessing. Honestly, that's what I'd probably do with this one. But let me show you this method that's a pretty solid method. Excuse me, it's called slide and divide. So we're going to multiply this 7 over here. So I get n squared minus 12n minus 28. Now what did I just do? I basically created a trinomial like those previous examples where the lead coefficient's 1. That's just a little easier to visualize for most of us. So now let's break it up. So I want two numbers that multiply to make negative 28 that also add to make negative 12. Okay, let's see what we've got. So 14 and 2 I think is going to work for us. So how about n minus 14 n plus 2? So negative 14 times 2, that's negative 28. Negative 14 plus 2, that's negative 12. All right, but we're not done. Because we created this trinomial, that wasn't actually the original. We multiplied that 7 in. Now we need to divide it back out. So watch how I do this. I'm just going to divide each of these pieces by that 7 that we put in, and now we'll simplify it, okay? So n minus 14 sevenths, well that's just n minus 2. And watch what I do here. 2 sevenths will not simplify. So this 7, I'm just going to slide right up here in front of that n. So 7n plus 2. 7n plus 2. Now that may look a little complicated, but once you have it down, it's a slick little method to work with these. So n times 7n, 7n squared. We got minus 14n plus 2n. There's our negative 12n. Negative 2 times 2. There's our minus 4. Okay, let's try the next one. Similar deal. And again, there's different methods you can do this. This is just one method that I've found success with and students like. So, can't divide that 5 out. Let's multiply it over here. So p squared plus 11p plus 30. 5 times 6 is 30. Now, let's break that up. What are we going to get? So p and p, factors of 30 that add to make 11. Well, how about 6 and 5? So plus 6 plus 5. Okay, remember the next step? We're not done. We multiplied that 5 in. We need to divide it back out. So just divide each of these numbers by 5. Now 6 fifths won't simplify, so we're going to slide that guy right up there. So 5p plus 6, and 5 fifths is just 1, so we get p plus 1. Now 5p times p, 5p squared, 6p plus 5p, 11p, 6 times 1, hey 6. That's a pretty slick method, okay? All right, I got a couple more examples here. 81, woo, that is big, and I do not want to do 81 times 16 and start listing factors. You could do it. It's just not going to be a very pleasant experience. So here's something I want you to look for, especially if you see bigger numbers. Is this and this both perfect squares? What I mean by that, if I took the square root of 81x squared, is it nice? Yeah, it is. It's 9x. If I took the square root of 16, is it nice? Yeah, it's 4. So let's just break this guy up. So this one is going to be perfect squares here. And so it's going to be 9x, and then it's 16. So we need numbers that multiply to be positive, they add to make negative. So minus 4, 9x, minus 4. So 81x squared minus 36, minus 36. Okay, that makes negative 72. Negative times negative makes positive 16. Or, of course, you could just write that 9x minus 4 squared. Okay, so that's something to look for, especially if you got some big numbers here. Now, if they're not that big, you can just do slide and divide, no problem. But with some big, hairier numbers, I would check, are they nice, perfect squares? Let's do one more like that. 9 times 32, well, that's big. I don't really want to do that. But 9 is a perfect square. 32 is not a perfect square. Okay, I thought I changed that problem. And so, all right, I thought I had changed that problem on the paper because I had some specific types of examples I wanted to work out, so I apologize for that. Okay, let's look at this one. Just ignore that guy. Okay, that was a big, those numbers would not have been real pleasant to factor. I'd have just done guess and check on that, by the way. So, 16, 49. Hey, those are both perfect squares. This would be 4x. This would be 7. So I get 4x plus 7. 4x plus 7. Let's see if that works. 4x, 4x, 16x squared. 28x plus 28x. Hey, that's 56x. 7 times 7. Hey, that's 49. So if you want, you could write 4x plus 7 quantity squared. Okay, I know that's kind of quick, but try to give an overview of some different problems there. Maybe let me show you one more type example while we're here. What if I had something like this? X squared minus 9. Can I factor that? Well, there's only two pieces, but think about what I'm doing here. I want two numbers that multiply to make negative 9, add to make 0, because I don't see a middle term. Oh, plus 3, minus 3 would do that. They have to be the same number, just opposite sign. So this would equal x plus 3, x minus 3. We call that a difference of two squares. The terminology to me is not that big a deal. Let's try another one. How about x squared minus 64? Two numbers multiply to make 64, negative 64, add to make 0. Well, again, what's the square root of 64? 8. They just have to be opposite in sign. So x plus 8, x minus 8. So if you see something like that, those are really quick, pretty painless to factor. Okay, I hope that helps. As always, if you have questions, please reach out to me. It helps if you have specific things you can send to me. I'll try to follow up with you.